So basically, this presentation will simulate, will simulate the entire pathway from the beginning to the end, and including this emerging technology. But for the emerging technology, we need to build up this physical model first based on the experimental work, and then all the substance properties and the reaction kinetics has to be developed based on the laboratory work. Okay, of course, for this process design, we need to consider any potential mass and heat flow integrations to maximize the profit of the process. So this slide illustrates the basically 3 levels of this LCA study in this process design. So first, the first one is for the process selection is here basically we will use this fixed process unit structure. It's already fixed, and we will use process simulation to simulate this material flow, energy flow that will be used for the environmental impact analysis. And but actually for this process is most often used. But for the process design, there's no feedback from these life cycle analysis results to further improve this process design. So instead, for this step 2, the process optimization, we will, the flow is fixed, but the operating parameters of the emerging technology and any process settings can be further optimized. So that means there will be a feedback loop from this LCE result back to this process design and further to the optimization. That will be very helpful for the technology development team. And for the further stage, and this LCE can be further implemented for the process synthesis process. And actually, that will be in that stage, the flow sheet can be further optimized. It means for the upstream and downstream, you have different alternative options for those unit selections. So that will be further utilized in that area. But my talk will focus on this middle line process optimization. So we know there's a lot of operating parameters that will affect the final, economic and environmental impact results. So normally, when a technology designed to maximize its profit, usually it will also increase its environmental impact as well. So there's a trade-off between these 2 objectives. And actually, if you consider more objectives, for example, for the land use or the toxicity of this process, contamination, etc., you have the trade-off between objectives. So this multi-objective optimization process will be integrated in this process to help us to search for optimal solutions. So in terms of we aim to find this optimal solution. For example, for the both economic and the environmental benign solutions quicker. So in terms of approach, this is based on my understanding that there's 2 approaches available for now. But for this first one, this multi-objective optimization is integrated directly within this internal loop of this LCA together with process simulation process. But we know this process simulation is very because of the nonlinear nature of this operating procedure. So this process simulation is tedious. Of course, one simple way is if you have this equation-based methodology for this process simulation is easier. But if you want a detailed simulation of this process, usually it's nonlinear. So we need the commercial process simulation software. So you can integration of this multi-objective optimizer within this process simulation process is little time consuming. It's durable, but very time consuming. So recently there's another approach coming up with the AI-based algorithm solving model. Just now the previous presenter mentioned this as well. So basically it's a combination. As the first step, we need to use this process simulation and the LCA model to then reach a training data set, maybe some amount number of training data set. And based on that, we will use this neural network and to simulate this model to correlate the operating parameters with its resulting economic and environmental indicators. And then use this hybrid model in this objective optimization process to further find that trade-off profile between different objectives. So this paper claims it's much faster when comparing with another alternative approach. But challenge still remains, because we need those large training data sets. Once we have a very complex chemical process, the model is complex, it's larger. But this is so far the most efficient one. So this is almost the second last slide. And so this is the project. This slide I want to introduce you. One of my current project is so this project will be focusing on this conversion of the waste to the energy to the fungible fuels, this technology. And so both this hydro thermal treatment technology and this biological treatment technology will be combined together. Basically, this hydrothermal treatment will convert this any types of waste. It can deal with any type of solid, liquid, and will convert that into hydrogen and the solid carbon, hydrocarbon, and the waste liquid from this process will be further treated by this molecular treatment process, and then produce renewable natural gas. This is, and of course, the treated water will be further back into use. So this is the process concept. We will use this life cycle optimization approach to assess this integrated process to see if it's climate mitigation purpose and also if it's economic viable. Okay, so I won't talk too much. This is a kind of a process we are going to have. We need to first build the big model and use this process. This will be based on the experimental work. There will be a lot of laboratory work election at the same time, and use this process simulation, and we will use based on the data we will generate both economic and environmental indicator definition, and so of course the challenge still existing. We would like to explore those two possible approach for the life cycle optimization, and so finally we would like to, okay, eventually we want to use this methodology to identify those optimal configurations. Because we know this process can treat different feedstock, waste feedstock. We want to know which configuration is more efficient or towards our climate change mitigation objective, right? And so, okay, so at the end, I'd like to call for collaboration from any graduate students. So in terms of this programming, coding, and for this methodology development, of course, there's some existing approach in the literature, but if we can further implement it and at the same time further develop this toolbox, it will be great, particularly for this complex biological process. Okay, thank you very much.